So, Gintaras Pelenis, work for VMware Blockchain team. Uh, I don't know how many of you heard about VMware Blockchain. Yeah, I know some guys which work internally at VMware don't count, but some of you know. Awesome, yeah. So we kind of started this as a research work a couple years ago. Well, it's probably like 5, 6 years ago now. And it really kind of was focusing on decentralized trust engine initially. Right, so I guess this afternoon is really great to kind of start talking a bit about distributed computing systems and the protocols, right? So what we kind of did at our VMware research team, research group actually, 5, 6 years ago, we're kind of trying to address the problems we've seen with blockchains overall, back those days. And what you had, there was obviously Bitcoin, you had Ethereum, a couple other emerging protocols which kind of like been present back those days, and they're all power hungry now. They're all quite slow in a sense, and doesn't really fit the needs of modern enterprises, right? So if you want to have like enterprise adoption of the blockchain technology, we're talking speeds and feeds and performance and security and all of those things. So that's kind of was really the goal initially. So I promise that's not going to be technical, right? So it's not, right? Yeah, so really the core foundation of the product itself was the consensus protocol. And consensus protocol, in kind of its pure nature, what it means is that we all can agree on something, right? So it's a very straightforward way of doing things. So we kind of grabbed something which was known as the BFT, which is Byzantine fault tolerant protocol. And BFT is trying to solve a problem with business in general. So I don't know if you heard about it. Anyone? No? Yeah, some of you know, right? So fundamentally, the idea is, I'm standing here, I'm telling you something, right? So you can all agree on the same message I'm delivering you, right? Imagine the situation if, we take this room and we place you all apart, like miles away. And then I would just be talking with you by sending messengers, whether it's, Vivek, right? Which is going to give him, a couple of different notes, and he will just be walking around and giving you different messages, right? Well, yeah. So a couple things in that space is that you cannot, first of all, trust myself, right? You cannot maybe trust, in the messenger, and you may not trust yourself, right? Fundamentally, the idea is, I'm sending the message to you. You all need to agree that this is something. Let's say I'm telling you A, right? So Vivek brings you A, you get B, you get C, and so on. So fundamentally, how you all agree on it. So this is the stuff, what BFT is about. So I know it's technical. So it's always, primary backup, so it's a leader and the replicas in it. We kind of worked a bit, on tweaking and tuning that thing. So I'm not going to go very deep technical. So, so those of you who know will understand. But fundamentally, we changed the protocol in a way. We published that. We open sourced that as well. So if anyone heard about Libra? So they actually used this one. Yeah, so they kind of used the research work, our team did, and another protocol. So this is SBFT. This is what we have in the product. We have another one called Hot Stuff BFT, which basically keeps rotating leaders in a way. So Libra BFT is actually built on the same thing, right? So it's much more faster than any other protocol. It gives kind of almost instant time to finality, meaning that if I'm sending the message, most of you will get that in sub-seconds. So if you do your job, your work with Ethereum, Solidity, or the public kind of blockchains, you always write it and basically wait until the transaction gets committed, right? So in this case, it kind of like moves quite quickly. Actually, I have a clicker while I'm walking around, right? Yeah. So what happens is basically I'm sending the message, right? That's the first phase, basically proposing it. You guys sign it, return it back to me. Then primary creates something called multi-signature thing. Again, it's a BLS threshold signatures for those who care, and basically all replicas executed. So all of this process is kind of like sub-second. You can deploy those nodes globally, if you will, right? So you can deploy them in states, in Europe, in Asia Pacific, and so on. So in that case, physics still going to play the game because what's going to happen, you need to send that block first time, right? So this phase really depends on the network, as such. Other than that, so this is kind of the core thing which we kind of worked on, and when we had this protocol sorted and fixed, so it's very efficient. It does scale a lot. It doesn't consume almost no energy. If you look at it, from like protocol standpoint, it's very lightweight, right? You just keep sending the messages and that's it. There's no mining. There's nothing in it. It's just a virtual voting, in a sense. So this kind of led us, to think what we need to do with it. Because fundamentally, BFT protocols or any consensus protocol has nothing to do with the blockchain. It's just a consensus protocol. You can place a file system there, you can place a database there, you can do whatever. You can do like, license manager, if you will, right? It has nothing to do with the blockchain. So we got the protocol and kind of thought, okay, is there a need for the blockchain, right? Checked around, spoke with the folks, out there, companies, corporates in there, and they say like, yep, blockchain is an interesting technology for us to use. Want to, explore that. But really what we're looking and with what we don't have in the market at the moment is kind of like operational aspect to the blockchain. And you've seen many of the startups, they're coming there with ideas and everything. And fundamentally, if you're a small company or starting something, you want to focus on your kind of key value proposition with the product. Most of the enterprises, on the other hand, they have their established teams, operational teams, security teams, and things like that, where every single product you have to go there needs to meet a huge list of specific requirements. So our kind of idea was that really we take this kind of core BFT product, added the blockchain layer on top of it, which is kind of like persistence basically, and then focused on day two. So how you deploy that, how you manage that, how you deploy that across many different environments and organizations, right? So not just sitting somewhere on AWS or Microsoft Azure, because if you talking about consortium, and like in our challenge, we're talking about kind of addressing plastic pollution problem, right? That means that you may have many different stakeholders and members in there, and they all come with their own kind of ways of how they want to do things, right? Someone is a lover of Azure, someone is a lover of their own data center, someone is a lover of AWS, etc. So you need to kind of address all of those capabilities with it. And I guess the third one was really developer friendliness. So yeah, just not make this as a rocket science, right? That's easy. So blockchain fundamentally is the very low level platform, right? Or the protocol. So people should not care about it. It's like you using internet. Like how many of you do care about TCP/IP? I know Mike does. But really, you don't think about that your device is connected there. There's a MAC address. There's routing tables, ARP tables, and stuff like that existing, right? You just use it, right? So that's fundamentally what blockchain should be, in the future if you want to get it adopted at a mass scale. People should not care about technology. And you actually will hear from Vivek, later on talking about DAML, which is an execution language, like the protocol language. These guys actually doing the same thing for execution kind of layer for the contracting language, making sure that it is simple and you don't need a bunch of developers trying to hack something and where folks just can't read the code as such. All right, so yeah, so simplify the way it looks like. Really, you have the consensus protocol as I mentioned, right? Then you have the persistence, which is basically storage, where you write all of your data in it, and this is where kind of like blockchain itself starts to happen, right? And then on top, we support multiple languages. So again, in true VMware fashion, we like to virtualize and abstract everything, whether it's storage, networking stack, or computing stack. It's very similar to what we did with the blockchain as well, right? So abstracted it quite highly, so we can plug kind of any execution engine in there. So the DAML, digital asset modeling language, or Solidity or chain code from there. Any blockchain starts with a node. Everyone heard about it, right? Whether it's Ethereum or Bitcoin and so on, you always have nodes as such. So we have two types of nodes. We have committer nodes and client nodes. Basically, committer node is the node which has participation rights in consensus. They do agree on all of the stuff in it. And there's a lot of technical details in it. With DAML, so we have DAML engine in there, which kind of executes the contracts. We also have a client node, which may or may not be participating in a consensus. It's basically a lightweight copy of the committer node, and also is helpful to do things like data segregation, because privacy on the blockchain is an interesting concept, right? Everyone sees everything, everyone is happy about it, but fundamentally not all participants are actually willing to join open networks, because you may leak your commercial secrets or things like that, right? So you need to have some kind of privacy in it. Yeah, the way it works, very similar to whatever any blockchain implementation you've seen in life. You have the client which connects somewhere to an endpoint. It can connect to the committer, it can connect to the client node. You can have many clients, and those clients, and those nodes actually multi-tenant by design, meaning each client will have their own kind of access rights and roles. If they're committing kind of connecting to the client node, we can even provide like full data segregation. So let's say if you're company A, you will only see the data belonging to company A, or in relation to company A and B. So Vivek will kind of talk about parties, I guess, later on in kind of like that DAML piece. But DAML has an interesting concept of parties. So when you kind of design, all of your contract flows and so on, you really need, to have someone to sign it, right? Let's say your data live. So if you sign up, your contract to attend this university, it's signed by someone, the head of university and yourself, right? So then it kind of gets into the power. It's the same thing. If you want to model any smart contract, on a blockchain network, you have to have, parties signing it. So what we do is basically we take those parties from the DAML template itself, which we model, and kind of pass them in the underlying infrastructure. So in that case, let's say, I agree with Vivek on something, that I'm going to buy something from him, he will sell something to me, and we will only be able, two of us, to see that data on the node. Everyone else won't have an access to it. It's a managed service, so we have all the fleet management stuff. You remember I spoke about day 2 operations, upgrading, patching, rolling upgrades, auditing, whatever not. So typical thing you would see on any kind of enterprise thing, right? So logs. We have developer section where all APIs documented and some sample codes there, etc. Really like basic sample deployment. You have a committer network, you have client nodes. It's all deployed for the same fleet management and deployment service. And it is a managed service by VMware. If we're talking like VMware Blockchain, which is a commercial offering we have. So we provide all the support, 24/7 by forever, and things like that. Project Concord, which is our open source release of the core component, is available in GitHub, so you can actually go there and grab it. We have 2 of those. We have the Concord BFT, which is the consensus library. So it's a bunch of C++ code, actually. So, if you're really geeky, you can go and take it. We have the Concord open source build. I don't know, Albert is live? No? Yes? Where's Albert? Is it live? Yes? Yeah. It's okay. Yeah, so Albert has an open source build. So we actually have an open source thing, so you can pull those binaries, build themselves. So it has like a sample implementation of key value blockchain. The persistence layer, has an execution engine in there, has consensus. So if you want to build up, your own networks or hack on top of something like that, feel free to have some fun. I guess those who've been yesterday in challenge deep dives, that's a slide taken from there. So as you see, we have a bunch of interesting companies there. It's a very crowded slide. But ourselves there, digital assets, together with us in a hackathon. We also have folks from Dell Boomi. There's Mike waving there. So Mike is the global architect at Dell Boomi. Dell Boomi is really like an integration platform, right, which allows you to plug different things together. So blockchain in itself probably won't solve all of the problems. You still need databases. You need different sources of data to be plugged, and kind of creating an ecosystem, let's say. Especially for the plastic and everything. So this is where Boomi really shines, These guys have the platform which is almost like no code, right? So any one of you which is not technical could actually go there, drag and drop components together, build the processes around it, and create something fun, right? Distribute applications, creation, whatever not. All right, so I'm kind of done. So now we're gonna have Vivek talking about DAML. Any questions, by the way?
You said that that for the Odyssey teams there's enterprise. Is it free to use this?
Yes. Oh yeah, sorry. I had a slide and forgot to mention. Yeah. So what we're gonna bring? So we're gonna have a bunch of folks during the hackathon weekend. DAML's bringing the full set of their kind of engineers who can help write DAML. We will have a bunch of folks. We will give those instances to anyone, to be frankly open. So even if you guys willing to participate in different challenges, not even ours, feel free to reach out to us. We will have a series of trainings before the hackathon, right? So we're gonna deep dive into more of the platforms, technologies, and stuff like that. But fundamentally, as I mentioned, right? So blockchain is made to be simple. So you'll see now with Vivek talking about DAML. But really, in most of the cases, you won't even see that infrastructure. It's just a backend layer, right? It's almost like running your applications and from time to time connecting to the backend database to make sure that everything is fine, right? So that's the intention of it. But yeah, you can definitely get the instance of that. And I think Boomi will also give their own instances there as well. DA gonna have so yeah, we have plenty of tools in our kind of toolbox here. Anything else? No? All right, so we can talk afterwards.
Yep. Thank you. Hello, everyone. My name is Vivek Srivastava. I work for Digital Asset. Thank you. We'll cover a bit of DAML. That's our open source smart contract language created by us. So, quick introduction. So, just like bulk of you who will be participating in the hackathon, 2 years back, I actually did participate in the hackathon. At that time, it was block changes, and it was really fun. We came up, basically we were the first runner-up in the identity track, and to be here in 2 years' time and co-sponsoring basically the challenges, it's really good. The philosophy from Odyssey, it's about co-creation, right? And what essentially the participants here, the sponsors, the Jedis, we are here to help each other and basically solve some of these challenges posted. And for that, the key thing is to basically collaborate, okay? So from this session onwards all the way till the April hackathon, I would say don't feel shy. If you have any questions, you need help, you want to try out the tools, reach out so that we can help in terms of anything that we can provide from digital asset perspective, VMware perspective, and have fun. It's really that 48 hours event is really fun. So who are we? So DA, Digital Asset, is a software company. We were founded roughly in 2014 with a few folks from DRW, that's the hedge fund in Chicago, and from that point onwards, we are our passion is to get developers really productive. So what Gintaras mentioned, we are talking about the technical aspects. We want to create a tool set so that the business guys and the developers, they can focus on your business logic, okay? You don't need to worry about the underlying plumbing. And that's how we can enable you guys to have web-based innovation in this domain. From history perspective of the firm, so we just raised Series C funding, which was announced 2 days back. Some of the investments there. In between, our biggest flagship project is with Australia Stock Exchange. So Australia Stock Exchange is replacing their clearing and settlement system for equities using our tech stack. And we work with other clients in financial domain, in healthcare, in supply chain. So from the tech stack perspective, it's industry agnostic, it's segment agnostic. Okay, so if you look at basically in the DLT industry, what has been the trend? So a lot of company for 5 years back, just like us, started with full stack, right? Everyone had their own smart contract language, their own platforms, and over time, what we have seen is that the bottom 2 layers, essentially, are getting more and more commoditized. We have seen big players like VMware jumping in, no pun intended there, and like other entities like Amazon, QLTB, many other big firms are coming in, and the bottom 2 layer, which are about data synchronization and the persistence of the data, they are getting commoditized, right? The business differentiator is on the top side. That's where you create new opportunities. That's where you are creating your business logic and adding smart contracts to improve things, to create a new business model, or to implement a new business model, or make existing things more efficient, okay? And we, as a firm, we primarily have focused on the smart contract layer. That's where DAML comes in. You will see in a few slides why. So again, why we started to focus more on the smart contract layer, and the key thing was about portability, right? So in terms of, as I said, if you look at existing tech stacks, right, you have to basically make that decision that what platform you have to pick right now. Okay, whether you want to use Sawtooth, Fabric, your Corda, but we do not want basically that to happen. We want the business to really think and focus on the business use case, so that you can solve the problem that is in front of you and not worry about like what kind of platform you need to tie up or buy in today. That decision can happen later. You solve the business case, you prove that this business case actually is commercially viable, and then you can decide based on your trust assumptions, privacy requirement, non-function requirement, that what kind of the underlying platform you really want to run your system on. Okay. So DAML is portable, which essentially means that when you write your smart contract in DAML, without a single line of code, change of code, you can actually run on any of these platforms along with a SQL database. So you actually don't even need to start with a blockchain. You can actually prove your business case on a traditional database. And then when you have the stakeholders who really want to have their own nodes, and that basically becomes a real business use case, that's when you move to a DLT. So you don't necessarily start with a blockchain in mind. You only focus on business use case and solve that problem. Okay? So one example of this in action was that Australia Stock Exchange, working with us for the last 2.5 years, they were using our own ledger for all this for 2.5 years of development. Late last year, they lifted and shifted their existing code base and ran it on VMware Blockchain without a single line of code change. And that's all of their clearing and settlement system. Okay? That's the power of portability. If you think of in today's world, if you have to do that even from basically a database 1 to a database 2 migration, it's most likely a 2-year transformation project. We do not want to get basically tied in that kind of a scenario. Okay, so how do we do that? So that's an analogy we often give. So if you want to create a really good model, and if you want to use clay, you really need to be skilled. Okay? But with some restrictions, for example, in Lego, you have Lego pieces. It doesn't let you do everything that you can using clay, but pretty much anyone can create very beautiful models, along with they are more safer. So we created DAML, which is a digital asset modeling language, which is a domain-specific language, with these restrictions, primarily so that the developers do not necessarily need to be aware of the underlying cryptography, how the blockchain works, how the protocol works, all of it, right? You focus on your business, and that's what you write. So this is so DAML is built on top of the building blocks of rights and obligation. So if you think of any business workflow or any asset if you want to model, ultimately what you're defining is a set of data and then rights and obligation of the parties involved. So let's take an example of a rental agreement. You're defining your rules between the landlord and the tenant, right? What are their rights and obligation in that contract, okay? So when it comes to DAML, for example, here we are just creating a CO2 credit. So templates are where you define the rules. That's your rule book, okay? That's the code you write in DAML. And then when it gets instantiated with the signature of the stakeholders, it becomes a contract in DAML, okay? And as these rights and obligations are executed, the proof of it, basically with the signature of the parties involved, gets stored on the underlying ledger, and that's how you have the full provenance, okay? So to get more in-depth knowledge about DAML, we'll have a meetup later today where you actually bring along a laptop. We will, all you need is internet access, and we have a web ID. We'll actually do live coding. And you will see that within ballpark, somewhere between half an hour to an hour, you actually will have an application written without knowing anything about any of the underlying blockchains. And you can actually validate that in that period of time, okay? So don't believe me, try it yourself in the evening. Some other links basically on our SDK. So it's an open source smart contract language. So you can go to DAML.com. There's a wealth of documentation as well as a lot of examples from ourselves as well as our partners. So many of them have been open sourced. Some of them are not open source, but they are available from our marketplace. You can play with it, learn. It really is a very unique, I would say, language where even when we often say that maybe a developer might end up writing it, but a business analyst can easily read it and validate that the code is good. That's about it from me. Thank you. It's over to you now to actually use the time from now till April and get involved and participate in the hackathon. Thank you.
Yes, thank you. Are there any further questions? Maybe we have some time left.
Okay. Basic understanding of code here, but if you write a template, I don't think I need that. Okay. If you would write a template and you have your field and choices and you then put it into a contract, can you still change your template?
That's a brilliant question.
Okay.
So ultimately, when you upgrade a template, is nothing but another workflow.
Okay.
So from DAML perspective, what you do is you can actually define how to upgrade your code as a business logic, not as a technical operation.
Okay. So if constraints change or if you want to
Yes.
add information, you can still do that.
Yes, you can do it, and you don't need to necessarily stop anything or do it. It becomes a business process.
Any others? No?
Oh.
Hi, thanks for your talk. So you're abstracting away the implementation details on the ledger level, am I correct?
That's correct.
So how do you handle any breaking changes on the underlying APIs?
That's a great question again. So we often work with our partners. So like, for example, we are working with VMware to get DAML running on their blockchain. So when basically, say for example, an upgrade from VMware comes in, so we'll work with them to make sure that, if there's the DAML and the DAML runtime engine is compatible with the underlying platform. So we work with our partners to support that.
Any others? Oh, yes.
Hi, thank you. So as a consumer, so like when I use the smart contract that's being deployed by someone, how do I cope with the changes? For instance, if the blockchain changes, how do I know that as a client, as a user of this smart contract?
As a user, it should be seamless to you. So if the entity who is running the platform, right, they decide that today they were running on blockchain A, right, and whatever be the reason, they want to move to blockchain B. So from their perspective, if they are using DAML, they have the benefit that they don't need to rewrite the code and anything. They can move from blockchain A to blockchain B. To you, it should be totally seamless. Why would an end client really need to know, what's the underlying ledger, as far as it meets your requirement? That's a, I would say, a commercial discussion between, for example, that as a client, are your, for example, non-functional requirements are met between blockchain A versus blockchain B.
Right, so if I'm a client, I also need to use the DAML SDK or...
Okay, so that's...
on both sides.
Yep, yeah, so, okay, so great question again. So the two level of abstraction that DAML gives you, so one is the underneath with the ledger partners. The other is that we have our ledger API. It was mentioned in one of the slides by Gintaras, which is basically a gRPC-based API. So essentially, you can write code in any of the supported languages, and you can interact with any ledger that is supported by DAML, or that is DAML-driven ledger. And that interface does not change just because the underlying ledger is changed.
So how do you, if somebody has a contract, if somebody has a contract, and the people out there decide they change things, they can't change your contract.
No. So contracts, in the slide where I showed templates and contract. So let me explain the two concepts in a different way. So in the rental agreement, the piece of paper that has all the terms and conditions, okay, that's a template. That's the rule book, right?
Yep.
Once you sign it
Yeah.
and put your address of the property and the rental amount and all that, that becomes a contract, okay? And it has a signature of both the parties, okay? Now the contracts in DAML are immutable. So the only thing you can do is you can exercise the choice if you have a rights and obligation to do anything on that contract, okay? So the contracts are immutable, and what happens is as part of your workflow, basically your business logic, you will have, once you exercise a particular choice on that contract, the contract can evolve to another contract based on another template, or another version of the same basically another contract based on the current template. And that's basically the two contracts will be linked together. So you have immutable contracts that are linked together based on the action that are taken by any of the stakeholders.
But the written version that I have is
Yeah.
still valid.
So-
The people up there can't change it and make that invalid.
So the contract, no. So if you want to change the contract, then it has to be defined in the rule book that I can take in this contract, and this contract can evolve into something else. But that is part of your rule book. That's the code you have to write in your DAML smart contract.
And the client who signed the contract knows the contents of their own.
Yes, exactly.
Okay.
Yes, these are shared rules. Yes, exactly.
One more?
Yes.
Say I am the new shiny kind of type and I decide to stop using DAML. How can I port my business logic?
So
I'm asking about my exit strategy if I decide no longer to use your product.
well, in that case, that would be no different from using any other technology. If you, for example, if your current system is written in, I don't know, Java, for example, or DAML, right? If you do not want to use any of the current tools, then you do need to migrate to whichever set of tools you want to use.
Okay, so there's no migration options.
Well, the migration option, it offers you to migrate from a database to a blockchain, or another like one blockchain to another blockchain. But as far as if you do not want to use DAML or basically the tool set at all, then I'm not sure what kind of basically option really we can offer, because we might not even know the tech stack that you want to use.
Yeah, that's right. Okay, thanks.
Oh, yes.
What are the revenue streams of DAML?
Oh, brilliant question. So how do we make money? So there are a few ways. Most importantly, when we work with partners like our ledger partners, so we have a OEM agreement. So that's basically we get some kind of a cut from that. So from the customer perspective, they are dealing with one entity, they are writing one check, and we get revenue from that. The other aspects are we also offer advisory services, where we can sit down with the customer, do a functional map of their business use case, help them basically architect a DAML-driven solution, and review their DAML models. So that's the second one. And the third is about your dev support side of things. And lastly, one thing that I missed to mention, we also, again, it's all about productivity, as I said. So using DAML, you can define your business model fairly quickly. We do offer something which is as a service, ledger as a service, which is Dabble, D-A-B-L, so you dabble with DAML, which essentially means that once you have written your smart contract language, and basically if you want to create a fancy GUI, you can literally drag and drop those artifacts, and you will have a up and running website like in 5 to 7 minutes.
Are there any others?
Yeah, let's give Albert 5 minutes.
Yeah, so then,
Sir.
so thanks for your presentation. So I'm up here just to show you like some of the environments that we built up, like a testnet, if you will, that you can get up and running on your laptops. before Gintaras gives you an instance, and so you can kind of practice a little bit, your hacking skills. So just to a quick refresher, so Project Concord is an open source project that took the Byzantine fault tolerant consensus engine that Gintaras mentioned that gives us the energy efficiency and the speed up, and we open source that. And so it's actually just a bunch of C++ code. And the way you can get to it is if you go to projectconcord.io and you go into developer. There are two links here. The one on the left, it says Concord BFT Byzantine fault tolerant, and that's a way for you to be able to download the consensus engine and be able to, if you're a C++ savvy, then you can actually help to contribute to it. But I suspect for most of you, the target audience is not for people to hack a consensus engine. That's actually our expertise, and we have actually a team of scientists doing that. You rather want to be able to, start using nodes that are running off this consensus. And so in the latter case, where you're more of like a hacker developer and you want to start running nodes on your local laptop, then you want to go to the link on the right, and it's just Concord without the BFT. So if you click on it, you're taken over to GitHub, and at the bottom, then we give you instructions on once you do a pull or download of the repository, then we give you easy to follow instructions on how to build the nodes. So if you follow the instructions, basically it does a Docker pull and it builds up the 4 nodes. That mimics a blockchain with 4 nodes running on it. And if you look into it, it's basically a open source key value store with Project Concord consensus engine, and then the Ethereum virtual machine running. And then you do once you do the build, you do the compose, which pulls all these things through a YAML file. It builds up a network, and now all of a sudden, voila, you have a little blockchain running on your own laptop. And then you go through the instructions here, and eventually you get the Truffle console, and you can use. I'm sure all of you are familiar with Geth or Truffle, and you can use those commands to interact with your mini blockchain. So I got it up and running on my laptop here through a virtual machine. Yeah,
it's a real demo. That's what it is.
Yeah, I can't type with one hand.
You haven't feeded your demo demons.
Yeah. Okay, so here's a virtual machine that's actually running. If you follow the 4 steps that are in the GitHub, you do the pull, you do the build, and then you do the Docker run. Eventually, you can see at the bottom here, you can see the 4 nodes are talking to each other. And then at the black screen over here in the terminal, then you have a Truffle terminal that you can use to interact with this network. So in this example here, I'm making some basic transference of Ether between 2 accounts that are on this network. And so once you have this running on your laptop, you can start thinking about our 2 problems that we have, decarbonization or plastics, and you can, we will work together to help you prototype some sort of solution. And then ultimately, if you want to track carbon credits, or if you want to be able to track plastics that are being thrown out into the ocean, this is a perfect environment for you to prototype and start getting your ideas fleshed out. So you can build this in about maybe 20 minutes or so. There's a chunk of C++ code that gets it compiled. So that takes about 10, 15 minutes, and then 10 minutes-ish, depending on your laptop, and then the nodes build up pretty quickly. So within 20 minutes or so, you can have your own environment up and running. All right.
Are there any questions about this? Okay, then thank you, guys. Where can the audience find you besides the meetup, and at what time is the meetup?
So the meetup starts at 6 o'clock, I believe. Yeah. Our stand is right at the speaker's corner, so you'll see VMware a stand there. So we will be around there. I would say even if you are not technical, do come for the meetup. And that's my promise, that you don't need to be technical to write DAML. Okay? Yeah. Yes, it's a great the location. Yes, it's. Yeah, so the meetup will be at the Innovation Playground, which is where the team stand is, where you are putting the posters for the teams. It's right behind that.
That's opposite. Yeah. Okay. Next to cafe.
Yes, please give them a warm applause.